Hi guys, and welcome to our final lecture for our series in NLP. So in this lecture, we're going to cover chatbots, and we're going to do this at a high level because the code that works for chatbots changes so frequently, I am tired of re-recording this video. So we're not going to cover any code in this lecture, but in class, we'll talk about some of the more recent code availabilities, usually from Hugging Face, but we'll see. Video might get 5 years old and I still be able to use it instead of having to restart every term. All right, so let's get started. What are chatbots? I feel like they're so ubiquitous in our life at this point that it feels a little silly to go over what they are, but let's talk about it. So they're interactive systems between a user and a computer, either through text or speech, right? So we could be chatting with the computer, either using voice or typing or texting, which is slightly different than typing on our phones, for example. And I love to use this example because it talks about how old I am, but Smarter Child was one of the first systems from something like AOL Messenger where it was really terrible, especially with what we have now, but you could talk to the system using instant messaging. But now we have things like Google and Siri and Alexa and obviously ChatGPT. So these systems have come a very long way. Okay? There's also custom chat bots for individual businesses. So you might have a little thing that pops up in the corner, like, how can I help you? And you're like, oh my God, please leave me alone, right? And things like UPS, FedEx, IKEA's is one of my favorite ones, but they're designed to help and trained for only the purposes of that website. So we kind of have these generalized ones and then these specific ones. And these conversations can take many forms. So, as a hearing and speaking person, I mostly think about them in forms of talk or text, but we could also imagine systems for deaf users that do video as well. Since all of these require some form of language, I'll be even more general here, chatbots are sort of the ultimate goal of all of the NLP tasks. So this lecture is at the end of the semester because it covers everything that we have kind of talked about. So how do you, put together proper sentences to respond to a user? We have to understand part of speech tagging, entity information, extraction, text summarization, right? How do you know what the user wants? The intent, well, that might be a machine learning problem. So we've kind of covered up to this point a lot of different topics that help us build and understand how we can get to these points. Now, sometimes it's not clear because there are individualized systems that kind of have already taken all of that background knowledge and made it easier for you to interface with. But when they break down, or you have these sort of specialized needs, you have to remember that what part of speech tagging is, right? So we kind of cover those basics so that if you didn't have a ready-made out-of-the-box system like a Hugging Face, then you could build one on your own. Okay. So a little bit of the history of chatbots because it's super fascinating. So they were some of the first AI tasks. Now AI is kind of this term that doesn't mean a whole lot anymore because it kind of means a lot of things, but it was one of the first like big kinds of tasks was to try to write these systems that you could talk to, right? It's almost the foundation of the Turing test. Right? And so one of the most famous early cases is Eliza, who was a chatbot system built in the Weizenbaum lab. And there's some very interesting historical stories from it. So even though people knew it was a computer, right? And they're like working on cutting edge stuff at the time, people knew it was a computer. They would, the research assistants, the secretary, the people who were interacting would attribute emotion to the program's responses and would like grow attached as if they were talking to a real person. Right? I think now it's a little different because we interact with them so frequently. But I definitely see myself doing this in the sense that I always laugh at how positive GPT is. So I'll be working on a really tough coding problem trying to figure out the answer, and it's like, you're doing great. And I'm like, I'm so glad that you're happy right now, but I'm not, right? So I think it's a natural human thing to attribute emotional responses to text, even if you know better, right? Now, DARPA helped move this area forward. It's a defense project in the US. As the military tends to do, they are the first consumers of new technological advances. So they were helping um, move these kinds of computer systems forward because they needed communication systems for their soldiers. Okay. Then that sort of transformed into these FAQ type systems. And I would say these are the nicer, easier ones to program because they're sort of limited in scope and they have kind of tangible goals. It's much harder to build dialogue systems, which we'll get to in a little bit, that are meant to be generalized. So let's talk about chatbots now. They're really common. You probably don't go through your day without interacting with one, even if you're not thinking about it. Okay. So with APIs, these systems are available to build for people to build without too much coding experience, right? So there are systems and um, interfaces that allow us to build them without trying too hard. So I know Amazon's AWS has one that's sort of drag and drop. There are many others out there. There are really great systems that I used to have lecture notes on that moved to not being open source anymore. And I always try to keep my stuff as much open source as possible. And then I really do love the interfaces at the moment from Hugging Face because it does make it very easy to have a system that chats. A couple lines of code can do it. So you don't really need a whole lot of coding experience to get started. One of the bigger issues is making sure that, thinking about the whole picture of the systems and being able to improve them. That's where a lot of that background knowledge is really handy. Okay. So let's look about the uses. So what are the most common places that use chatbots? Okay, this should not be a surprise. Everything at least in the US, is consumerized. So recommendation systems for shopping and e-commerce, helping with orders, helping with payments, finding a way to get your money to them, right? Helping news find what you want, right? Customer service, probably the most common place that most of us have seen these is taking complaints, answering FAQs, directing you to the right agent if it's a real agent at all anymore. It's sort of questionable in the background, right? There are medical chatbots, so helping patients fetch that information that they need, right? And many, many more. So those are kind of the common uses you might use during your day. Okay. All right, so let's look at some example chatbots. So this is a simple one from Amazon, right? So generally, the user enters some sort of question. The system then processes the question. So whatever model is running in the background, it might be a very simple regular expression model. If X, then print out Y. And it might be something all the way up to a large language model. So, lots of variation in the background. Okay. It looks for what it thinks the correct answer is, and then provides an answer. So processing the question first requires us to figure out semantic meaning. What are they asking? What is the intent of the user? Okay. Once I know that, I have to find the answer to the question, if there is one. Um, and then I will give that answer back to you. Okay. So this is one of the more interesting things about GPT sometimes is I have found that it's really good at questions that are sort of when you're using it in this manner that are sort of easy to verify answers from. But the more deeper and complex that you get, it tends to not make things up because it's not, I don't want to ascribe intent to a computer program, but it tends to connect dots that shouldn't be connected, right? So those are one way to tell where these systems can still go is verifying information. It's still a tricky task for humans and for programs. Right? So what are the types of chatbots? So we can have our exact answer or frequently asked questions bot. This is the kind of thing that you'll find on most like tech support or shopping commerce websites where there's sort of a limited set of things that you can ask it because it's easy to train, and then it has a limited set of answers that it might give back. Okay. It usually includes a fixed set of inputs. So if you've ever had one where you've like clicked the answer, and then it will retrieve the correct response. The conversation really isn't tracked. So from question one to question two, it sort of forgets that that's what was going on in the background. And this is an important component of newer models, is that they do track the conversation. A flow-based bot is more complex. Think of it as like a tree of forking paths, right? You ask this question, which leads to this one, which leads to that one, etc. So it is tracking conversation by the path that you've gone down. So once you've gone down this path, you can't sort of jump to this other one, right? So it maintains that information during your conversation. And then the one that we probably like the most are the open-ended bots. These are more for entertainment, to talk about many topics, or for help, right? So there's a lot of advertisement, at least, and this may be my own bias speaking because of what I do, that where I get ads for Copilot and other like sort of coding-based ones, because what I do. And that's not really for entertainment. It's meant to help me go faster at coding. Sometimes yes, sometimes no, right? But I can then ask it questions that I find sort of fascinating. Like one we asked recently was, how do alligators float? So, because I live in southern Louisiana, and it was sort of a question of like, wait, how do they stay afloat? So it is also for entertainment, but I use it for coding, for example, right? And there's no specific flow required for the information, right? So I can jump between topics. Now, uh, this is one limitation of current systems is jumping between topics does confuse it in the sense that if you wanted to go back, it sometimes doesn't understand context. And so we'll talk about this a little bit more later, but one thing about people is we don't like when context jumps around just a whole lot either. It feels confusing. And so it's sort of interesting that models, they don't react because they're computers, but can also have that problem. So here's some pictures of the types, right? So over here in our frequently asked question bot, there is like, it gives you the same answers over and over again. Are there limits to the size of the data set I can use for training? It says 100 gigabytes. What's the maximum size? 100 gigabytes, right? So it's giving you the right answer, but the change in phrasing doesn't change the answer. Okay? A flow-based bot is, if you're maybe ordering pizza online, it said, okay, what size do you want? What size do you want? What do you want? This, and this. Okay. And so that might be like going through a checkout. And then an open-ended bot allows for conversation to weave its way around. All right. Now, some things to think about when programming these, right? Is that generally conversations have some sort of goal. Okay? This is true of all of those different types. Let me back up here. So, right, frequently asked question bot, answer my question. The flow-based bot in this example, it's ordering a pizza. And the last one is a bit chaotic in a sense because it's going all the way, it's like weaving around. But it's more conversational, right? And so most conversations have some sort of goal. Okay? And so this is getting more into communication theory, which obviously plays a large role in some of these newer NLP tasks, um, where we're trying to exchange some sort of information. Now, that might be for fun, or it might be for ordering pizza, for example. Chatbots do this as well, where it's often business or domain specific. Okay, those are would say are much easier to kind of control because the use case, the scope of what you're trying to do is much smaller. Right? And anytime we can limit that scope, it does become an easier problem to tackle coding wise. Okay? And so to be able to do this, we do have to have that domain specific knowledge, right? To for goal-oriented dialogue. That does limit its generalizability. Now, I'm not saying that chatbot frameworks are generalizable, right? Most of their frameworks often are deep learning based, or so that might be transformer model like BERT, and that's where GPT and stuff work on. It might be a recurrent neural net model. it might be a simple regular expression model, right? So it's not, we're not really talking about the framework on which they're programmed. A lot of that is generalizable, right? Because otherwise we wouldn't have 6 million different versions of chatbot kind of models using transformers. I'm talking about the like once it's trained, that's where its generalizability can be limited, right? Because of the um, domain-specific knowledge that went into that framework. Right? And so the framework itself is often what people are working on when it comes to data science, right? And analytics, like how do I improve upon these models and their answering systems and getting them better, faster, smaller, right? Because now one of the problems that we see is that large language models are too big, right? Too much trouble. So can we build a small language model? And so we're using those frameworks and then putting the data on top. Right? And that's the part that limits generalizability. So for example, chitchats. Chitchats are open domain conversations without a specific goal versus goal-oriented dialogue. And then the chatbot has to be a bit more coherent. Okay? With goal-oriented dialogue, the answers can be um, not quite on topic, so to speak, but like they can be very forced choice. Like, I want a pizza. Okay, what type of pizza, right? I don't have to say that 6 different ways. Where is the where are your cute shoes, right? For a shopping website, and it would show me that. So like I don't have to have that with that goal in mind, the answer responses can be limited. When it comes to chit chat bots, um, it requires it to be a bit more coherent and on topic, right? And so ChatGPT is one of these types of systems. And I think if you've played around with it, I mean, a lot of us have, um, it's very popular. It you can tell when it's not on topic, right? It says something you're like, that's not what we were talking about, right? Like, and you do this with other people as well, where they say something back and you're like, what? That's not what I was talking about, right? Um, However, these types of systems are very expensive. That was a very expensive model to build, which is why they want to get their money back. Um, some of the newer models, like DeepSeek, have been cheaper to build and kind of a modification on a theme. But I would say that since they were able to do that because GPT was so successful, right? But it still was pretty expensive. I mean, it's not like 10 minutes of my time, right? That I can write with a dialogue, general goal-oriented dialogue bot. All right, so let's look at how these systems might work in an NLP pipeline. Okay. So if a model has speech recognition, so we might be able to cut this whole piece out and have it just be inputs. But if you're going to have speech recognition, like if I'm going to talk to Siri, for example, or Alexa, or Google, or any of the other home devices where you could say turn on and off the lights, right? You do have to have some sort of NLP system that does speech to text understanding, just essentially translating the sounds of the phonemes to the written form. Okay. If you don't have that, it does make the pipeline a little shorter, but then this component right here, natural language understanding, I have this a bit more in some other slides, but this is where systems are processing the text for intent and meaning, like what is the question? Is there a question? What's going on? What's the semantics, right? We do all this very fast. Computers are also fast, but I think it's kind of amazing if you think about this sort of wet hardware system that we have, how quickly we're able to do this. Um, and how often we go, what? Right? Like, huh? Um, so our systems are our systems mentally are very good at pulling background information and trying to determine context and then stopping when it doesn't make sense, right? Um, but let's say the computer's figured out, oh, you want to order a pizza. Then you will have some sort of dialogue manager that says, here's my input, this type of response is an appropriate thing to say back. Okay. Task managers are controlling like pulling information. It might be like if you asked it what the weather was, the dialogue manager would send it along and it would pull the API for what the weather was, right? And then send it back. So it's determining, oh, I need to queue this system over here to give me the information I need. Okay, I have it back. Let me put it into the right sentence and send it along. Okay. So these are kind of dependent on what you're asking it to do. And so early forms of GPT couldn't search the internet, so you were more talking to it. But now I could be like, "Hey, can you find me a link on Amazon?" And it will like go out and look and come back. Okay, so it depended on what you're needing here. This task manager might be get a representative. Right? Dialogue manager is telling it what to say, what type of thing to say back. The natural language generation area is like putting the words into that intent and meaning. Okay, I need something that, implies um, the weather for town here is blah, blah, blah. So it will generate something that is semantically and syntactically appropriate, right? So it's the right meaning and it's the right form of words glued together that makes sense. Okay. And then if it's a system that talks back to you, it will then generate the phonemes and say it aloud. All right. So not all systems will need that speech recognition, but a lot of them do. Okay. And this helps us transform that speech into text. So this is the text version of what we just went over, but just to make sure we didn't miss anything. So natural language understanding, where the system tries to parse the text. Okay, this is an important part that we covered a little bit as a means to an end in the information extraction section, right? We talked about dependency parsing. Dependency parsing really helps us understand like how things are connected in this sentence, and that really grabs at the meaning of words and builds the larger context. But then there's also constituency parsing, which literally is like this is the noun phrase, this is the verb phrase, this is what they want, for example. So you might use name entity recognition, co-reference resolution, like understanding the relationship between the last answer and this one, and then mapping request to the frequently asked questions, etc. Now the dialogue and task manager figures out like this is the important part, and it connects those inputs to required responses. So when I was training people how to use Rasa, essentially it allows you to say, okay, they're wanting the weather, run this weather API and come back to me. I'm gonna take that piece of information, temperature, stick it in the right place and spit it back out. And then natural language generation, which for a long time I used to say was the most complicated thing that we would, take a while to figure out. I do think we're good at generating natural language now. The issue now is sort of being better at mimicking coherence, right? That's the harder part that sometimes is still lacking in really good models. Okay. This could be template-based or generative. Template-based models, much easier. You have the sentence written and you plug in whatever piece of information you need. And those are sort of your FAQ or your flow-based bots. Okay, not so much your conversational chit-chat bots. Generative models work better for chit-chat bots. And we're pretty good at the generative thing, but you have to remember that most of language is statistical, meaning that the ability to predict the next word is not terrible because it's like a common set of probabilities, right? Given these three input words, the probability of the next word, you usually only have a couple things to choose from, right? So we can generate syntactically correct sentences pretty well now, but again, it's coherence that's difficult, making it semantically understandable. And then if it's a speech system, it will read the answer back aloud to you. Now, dialogue systems in general, so we're going to get into the ones that where you're chatting back and forth, require some sort of memory. Okay, this was a big jump when these sort of models with memory came out. So I'm thinking of like long short-term memory models, some of the older recurrent neural net models, then transformer-based models. It's a really great paper called Attention is All You Need that holds on to information as sort of attention memory, right? And that is such a cool concept because it does map onto how people work, right? But computers have a much easier time paying attention than we do, right? So it's sometimes better at remembering information that, we would have lost because we weren't paying attention, the TV was on, whatever distraction we're currently using. Okay. So dialogue systems to be good require some sort of memory about turn taking. Okay. And so to give you sort of the proper terminology from research in psycholinguistics and communication. Here's some ideas. So turn, it's the input from the user, okay, followed by the response from the system. So turn taking, like when you teach children, right, you wait for the user to finish and then it's your turn and you go back and forth, right? Um, then there's some sort of intent, okay? Most people in like data science and sort of that analytics field call this NLU, natural language understanding, but more traditional systems call this intent, right? So what is the user trying to get, right? What's the point of this conversation? What are they asking about? So this is where domain specificity can come in. If it's a chit chat system, obviously it's got to pull that information. We'll talk very briefly about RAG in a little bit, so retrieval augmented generation, okay, which is one of the newer things that models are trying to make sure it grabs that the right types of information. Okay. So once I figure out intent's kind of like topic modeling, right? If I kind of relate it to things that we've done, figuring out what's going, what do you want? Now, slots or entity is like where the specificity comes in, right? If my intent is the weather, the slot or the specific entity information, and these are some of the terms that RASA uses if you want to use that program, uh, is tied to like what information you would actually put in, right? So weather is like the overall intent, but the slot might be temperature. Okay. So we grab this sort of big topic and then we fill in what's appropriate for that topic. Okay. And models of communication and then psycholinguistics and reading and stuff talk about it as like people are sort of building this mental model of what's going on and then filling in the things that match or are appropriate by using their background knowledge. Okay. So a lot of newer chatbots use that sort of system where they are trained in the background knowledge to help them pull that information, right? So, for example, if I told you I had to wash my clothes, there's a lot of background knowledge there that people have about, because they've done it before. And so, you know that you would need some sort of detergent, right? I don't have to tell you that as long as you're familiar with the concept of it. So dialogue state or context, this is the point in the conversation we're actually at. Okay? So it's information about whose turn it is, what previous turns have happened, what the intent still is, and then any entities that have been filled in. Okay? So if you said, okay, the weather in southern Louisiana is 98 degrees or 40 for my European friends, right? 40 or 45, very hot. Right? So but what about what about Florida right now? And so that intent is still the same, weather, but we've changed like one of the entities, for example. So here's an example about ordering pizza. Give me a medium pizza. So intent, big intent. What's the topic going on? Order pizza. An entity would be some of the things that you need to extract from there. So like a named entity, but they're not really named. Medium is important. Extra cheese is important. Okay. Here's another example about getting stocks. So once we figure out that intent of the user, we can use sort of NER or information extraction type approaches for determining what those entities or slots should be. Um, and then systems that generate text to fill in those slots. Okay. So this can be trained using the same types of approaches we used in those lectures. I think now the systems are a bit more opaque. Right? So before, when people were writing very small systems, the each little piece of this component was programmed manually. Now, because of the types of architectures that we have using deep learning, it's a bit more of like tuning the model towards those intents and away from other intents. So once I know those entities and I kind of push my model that way, our response to those answers can be determined by providing a fixed response. And these are sort of the older systems where it was like, here's a list of possible responses. And these would be dictionary lookups using key value pairs. Right? Give me a pizza. Okay, what kind? Large. Right? That's what size. What do you want on it? Right? So we could use a semantic overlap system, like our recommendation system that we trained in the information extraction area. Okay, but maybe a little more complicated. We could use template responses. So these are sentences that are pre-built with waiting for words to go into them. This is a bit how simple Rasa works. Or we can use some sort of generation. Okay, this is usually a deep learning approach, but the great thing about working in data science right now is that we have these systems through, especially Hugging Face, which is a nice open source system that has already built these models, and sometimes in the areas that we're interested in to know how to generate those types of inputs. Templates are easier to write and train. Okay? And they often have less grammatical issues because you've already pre-written the sentences. And that's usually where I tell people to start because it will help you understand um, how to build and train bigger models. And so Rasa was one that we were using. It was like the second half of this lecture until they changed to their system. So as far as I understand right now, some of their newer systems are paid for. So that's why it's not in this lecture anymore. So let's look at those key components, right? So just kind of summing up all this stuff. There's this natural language understanding bit, okay? And that's where we're grabbing the meaning. So kind of a text summarization or topic modeling approach, the entities that are necessary for the response, right? From those user inputs. And that might be done in a variety of ways. It might be a fixed response. It might be a flow-based diagram like pizza. Okay, I'm gonna stick you to the start of the pizza chain. Okay, or it could be our chit chat type system. Okay. There's some sort of management system that's controlling that dialogue of what's coming next. Okay. There's some sort of system that's generating a response. Okay. This might be the template system, or it might be the generative part of Gen AI. And so now let's look forward. Right? So these are some newer slides that I've been researching. Let's look forward at what's happening now. Okay. So how do we go from systems like, UPS is can you track my order? And that's all it can really do. It's not very good, right? It's all it really do to these generative systems, these amazing models that we have, right? And so for a long time, this really was a simpler machine learning problem. I mean, it might have been deep learning, but still machine learning, where it was trying to fit into the mold of one of these topics, right? So chatbots were much more limited in scope. It had, track my order, talk to an agent, work on my account, right? And so it would move you to that intent and fill in those slots, right? But now chatbots like GPT, Claude, and Gemini are trained and then tuned, right, with prompt engineering, okay, which is just a fancy phrase for like trying to get the model on track, right, to understand and respond. Okay, so we've got to direct the model to where we're trying to go. And this is the part that I find, I think, probably the most frustrating when I'm using it for a specific task, and not more generalized, how do alligators float? Because that's a very dictionary-based question. So I am good at coding, but I'm not great at JavaScript. And when I am working in JavaScript, I'm also usually asking questions about how to fix something. And I find that the most difficult part is getting on the same page contextually, which I would have with another programmer, right? Or I would have if I were searching Stack Overflow, trying to make map, does this example map onto what I am trying to understand and how can I apply it? So I really appreciate having these models to talk to instead of digging through people saying that other people are dumb on Stack Overflow. Don't get me wrong. But this is the part that's like really hard. That sometimes I'm like, no, that's not quite what I'm trying to do. I'm trying to do this. Okay. And so prompt engineering is when you're like trying to get it to the question you're actually asking. Okay. You're clarifying, giving it more information in the background. Okay. And what that does, moving from these systems that are much more like hard-coded to these loose-based systems, is it does allow programs to be more flexible and more open-ended. And I think we're a bit more satisfied with them because they can handle our questions a bit more flexibly. I mean, I get frustrated talking to people, so I can get frustrated talking to computers. It does allow for these complex multi-turn interactions. That was a limitation of many systems before, where they could only remember so much, if at all. So being able to be like, no, don't you remember we have this, we ran this code before. I just can't find it in the chat. Um, I do think there's this new feature on GPT using projects. I haven't quite seen that it's much better than just having a new chat, but once you hit that chat limit, and you have to start over with that context. It can be kind of frustrating, right? So we are moving to finding ways that it remembers more about what you were talking about, right? And it's less dependent on if this, then that training data. Okay, so very rigid training data, but it does mean that it requires a lot of training data, right? So to build these systems that are actually good at this, just so much training data. Okay, thankfully, there is a lot of text bouncing around on the internet, but that also gets us into some ethical issues, right? So modern chatbots also, here's RAG, can use retrieval augmented generation where they have some sort of knowledge base, sort of background information that they can pull from using, some sort of API or dictionary lookup to help map. So the new feature in GPT and projects allows you to give it the background information to help bias context. So I'm able to be like, I'm using Postgres and I'm using React and I have this type of thing. And oh my God, TypeScript is super annoying and this and this and this. So I can give it that information and I don't have to tell it every single time. So what I think that probably does is bias how their RAG is working in the background. I don't actually know, but it's my best guess. So we could use a system I've talked about a couple times called Rasa. Rasa is really cool. It is an open framework, sort of, for building chatbots. And so one of the problems that I am having for it is that there's only a certain point, like it only supports certain levels of Python, and then they are moving towards like having a pro system for newer versions of Python. So I have taken it mostly out of my lectures because I can't always get it to work, but it's more of a really nice, smaller, context-dependent system. I would not write a generalized chatbot with Rasa. Okay? But it is a really cool set of programs. It might be something that you would like to use for Pro. I have no idea what it costs, but I did run into problems because Python has sort of moved on and they have not. So Dialogflow, which I have never used before, but found, right? There is a bot framework for Microsoft. There's also one that Amazon has built into some of their AWS forms that you can use. And then my favorite, which is Hugging Face, I've talked about multiple times, this time, which is the open part of OpenAI, right? Because they also have a closed part of OpenAI, that's GPT. But they're transformer-based models that you can use freely from Hugging Face. Now, how do we decide that a chatbot's any good? Right? This feels like a trickier question than simple classification that we just finished. Like those are answers, right? When you have um, supervised learning, where you are training a model where you have the answers, you can very easily calculate these accuracy, precision, and recall metrics, right? So I know I'm getting this many of the intents correct, and et cetera, et cetera. So we can still do that, but it's a little bit trickier if it's a chit chat model, right? Because maybe there's not like a human might be like, well, that's not exactly what I was talking about, but that matches somewhat, right? So that's not as clear as like, this is the answer and this is not the answer. So for generative bots, right, this works well maybe for FAQ bots. Um, there's this system, it's called Human in the Loop. It's really nice. I think this should be emphasized a lot more where we have systems in place that keep the human in the loop because and it's not because I think any of these systems are going to take over the world because I definitely do not. Okay, they're only as bright as we are. Um, but I do think having those human in the loop evaluations help keep models from going off the rails. Okay. Um, so having people rate how appropriate is this answer, right? Factual accuracy, or the hallucination rate where it's like making stuff up basically. Now people make stuff up, so I'm not surprised that models make stuff up. Where you've got, this topic and they're very similar and you sort of mish them together. Okay, sometimes this is called the misinformation effect. Okay. You just don't quite can't keep them straight. Okay, models aren't trained to keep them straight either. It's just kind of be fed tons and tons of information. So for example, in earlier versions of GPT, if you asked it to help you write like a research paper, it would make up um, references. And it was, a great time to be an instructor because it made it very easy to figure out that what students had done. It has now got some guide rails to not do that because they've trained it to not do that. But what's happening is like people who do the same type of work, right? So it's got this knowledge base, like this is all the stuff in semantic processing, my area, for example. And so it would grab the right people and the right type of title and just slam them together. Okay? So I would look at something and be like, I don't think that person wrote that paper. And I'd look it up and I'm like, no, I didn't write that paper. Now, that has happened to me recently. So it's not perfectly solved. It's the hallucination rate, as it's called, is still non-zero. Um, and that part's trickier for people who don't have domain expertise, right? So I always tell people, like, if you're going to use it to help you with research, have it help you look stuff up and then read it on your own. Okay? So we could mark how toxic it is, or sort of safety rates, making sure it doesn't recommend doing things that you shouldn't do. Okay. And toxicity really comes from sort of a Microsoft Twitter bot that they just let loose with no guardrails. Okay. And it turned into a Nazi. So, we do have to be concerned about how models react and learn from humans because they are learning still. You are generating more training data for them. So by using them, we are training them to do certain things, and we don't want to ethically have them go off the rails, as I like to say. Okay. Then it also could just be user satisfaction as well. So GPT at the moment has this like good answer, bad answer kind of system. Um, I do think I wish it were a bit more granular because sometimes like, well, it's not a terrible answer, it's not quite what I wanted, right? So I could give it like a 2.5 out of 5 instead of just bad answer. And so all those metrics can help us determine how well the model is running. And there are even more systems that people use, but this is kind of the general overview. Okay, so I've kind of been getting into ethics, so let's talk about ethics. All models are biased. understanding what their bias is critical. Okay? I think sometimes we lean towards if it's useful, we don't care, and that's really problematic. Um, my background is in psychology, so obviously I think a lot about human ethics because I gotta, I can't mistreat people. It's part of those federal laws. Um, and so I think we have to kind of also step back and think about what's going into them. So when the models are trained on the internet data, they inherit all of the things that internet data has in it. So there are bad parts of the internet that models definitely it had to work itself out. So I always laugh at how positive GPT is because internet data has a strong negative bias. And so they had to probably work pretty hard at making sure that it stayed in that area of semanticity. Um, because general responses tend to be fairly negative or neutral. So that is something that they had to train. But you can ask it simple questions to understand bias as well. So, I was giving a talk one time to Girls Who Code, such a cool program, and I can ask a GPT model like, "What should I talk about to boys with generative AI?" That's like sports, video games, cars. I'm like, cool list. I like sports and video games. Cars are useful, right? And then, okay, what about girls? It's like fashion and TV shows and gossip. And I'm like, also cool, but that is a heavy social bias of like what girls should like and what boys should like, right? So biases that you see around you every day are part of these models. So it's important to keep that information in mind. Privacy, wow, I could talk about deep AI, deep seek in its first couple weeks having like an open access point to their entire database, which is sort of not cool. I think the white hacker people found it in like a day. So obviously privacy is very important in these models. It's very important in a lot of places. Health data, um, and you might be asking it no questions about that you're trying to do on the job, but that's information that you're not supposed to leak out into the world. So anytime we're giving these systems information, we have to be sure that the system is trying its hardest to not be hacked. Now, it's not if, it's when. I think a lot of times when it comes to systems, they're never perfect, just like people. And so keeping in mind what you're telling models. Right? And so we've talked a little bit about hallucination already, but this more clearly is where it will generate something that's plausible but not actually correct. And correct sometimes is a bit tricky, like sometimes there isn't a like correct and incorrect, but my example of making up citations to support an argument is a hallucination example. Okay. And then jailbreaking, right? So making uh, keeping procedures in place to keep it from being hijacked, basically. And using the Microsoft Twitter bot as an example, something that got hijacked fairly easily, and they turned it off after like a couple days, I want to say, because it went wrong so fast. Now, consent, okay. This one's trickier. Did we consent when we built the internet for it to be used in this way? I don't know. When I was young, writing blogs about nothing, right? Nothing important. Did I mean for that data to be used in this way? I don't know. And well, it's kind of done now. I can't really go back. But like thinking about um, the ethics of web data scraping, I think a lot of people feel like, well, it's public, so it's public information, right? And that's sort of where the laws sit at the moment. But I think that's probably going to change of what can and cannot be scraped. So there are definitely different websites have different um, terms and conditions on whether or not that is allowable, right? A lot of data sets may or may not be ethically grabbed and collected, right? And so there's a lot of questions about Where does the data come from, and should we have put it together? All right, so how do we solve these problems? Well, um, it would be better if a lot more of this was open source. I get proprietary and like I want to make money, blah, blah, blah. But that sort of level of transparency um, should be part of these systems. Where's the data from? What biases does it have? How do we protect people's information? How do we keep it from going off the rails and telling young children to commit suicide, for example, right? How do we make sure they maintain these levels of control? So at least transparency and those kinds of things. Okay. User control and clear markers of human in the loop, right? So when I think jokingly for a while they were like offering this position, this high paid position about being able to unplug it if it ever got too smart. And I was like, that's one, it's kind of ridiculous because it's just a computer. But I think the point being more so the understanding like where are humans in part of this process, and how they are managing these systems. Okay. And then guardrails to prevent that misuse. Now, will people still talk mean to bots? Sure. That is the thing that people do. It's the thing people do on the internet. Just look at Twitter, right? Reddit, any of those other social media platforms. But keeping that kind of data from being training for the next person or the next interaction, right? So in these cases of misuse, making sure that data is not training data for what should be next. Instead, it's training data for what not to do, right? And that's where human in the loop is very important. So where to next, right? This is already happening, right? Where models are designed to adapt to you and answer you, right? So I remember when Siri first came out and I would use it for text to speech, and it was particularly bad at my southern accent, um, at getting understanding enough context to get the right phonemes, and it's much better now, right? And if you think about personalized ads, personalized agents shouldn't be a surprise. And I think people will like these sorts of things, but we have to remember what does that mean about us giving it our data, right? So if you're concerned about giving the internet your data, you should be concerned in using these platforms as well. Right? Multimodal. So this is happening at the moment as well, where I think OpenAI is sort of closing all of their different bots and like putting them into one. So I don't think you can really use Dolly anymore. It's just like part of ChatGPT now, but things that can handle image, text, and voice all at once, right? It just is calling different systems in the background effectively. Okay, I will say that GPT is very bad at making pictures. It's adorably bad at anything that requires the picture to have text on it. Oh boy, it's terrible. So that's something that models are we should work on to get better at, maybe. Right. On device models. Right. So I have a student who's working on cyberbullying and trying to design models that can fit on a phone, right? Now, GPT fits on a phone because I have the internet. But if we want a system that is more private and specialized to you, but private, it needs to not be on the internet, right? And so can we create models that run offline only on smaller devices? Okay. I know phones are not technically smaller devices anymore, but these models can be quite big. So can we do them without the internet, so to speak? Can we make them run in a limited way? And then, of course, there's a lower latency. If you're in an area with very poor internet, you're stuck waiting on the answer. But if I can put the entire small language model on your phone, I can answer your questions right then. Right? So I'd say if you're interested in like kind of where this is going, looking at small language models is kind of where people are kind of reacting to having models that are too big. And then hybrid systems, right? That take those template-based ideas and the dialogues and the whole idea of FAQ bots as a limiting factor. So, okay, we're only going to talk about these things in our model, but we're going to use the generative flexibility. So yeah, I'll let you order pizza. That's all you can do. But I'm going to talk not in a like if X then Y, and every time I use the same sentences, I'm going to talk to you a bit more flexibly. So these hybrid systems are kind of like updating those old FAQ bots so they're a little more natural in their interaction. Now, oh, random equal sign here. Inclusivity, many of these models are only in English, which is a problem with the internet as well, but it's very frustrating because many folks are multilingual. And so having models that could respond to them in their native or third or eighth language, or models that understand cultural nuance, right? So having having models that could say, okay, this is your location, so here are the types of things that I should and shouldn't say to you, or the types of word choices that you might make. Right? So if you realize you're talking to a young person, you might change to young person slang, for example, to make it a simple example. But I'm thinking also too that the way that you talk to somebody in a Muslim country might be very different than the way that you talk to somebody in the US, for example. There are things that are not appropriate to say, right? And so if you've ever traveled abroad, you've kind of tried to avoid those types of things. Models should do that too. So why should we build these? Right? We've been talking about it as if this was a great idea. But what are their use? Like, what is the point of the use cases of these systems, right? We've mostly ended talking about about chit chat systems, but in general, from a business and marketing perspective, they're a good thing, right? They could increase customer interaction and provide information. So if anyone has ever sat on the phone waiting on an agent, you know how frustrating it can be, how long it can take. Human agents cost money and time, there's training, blah, blah, blah. So sort of eliminating, not eliminating the people there, because you will always need them, right? There's some things that these models can't do, but eliminate, like reducing the volume, right? So that if you do actually have a question that requires human intervention, then it doesn't take as long. Uh, is the IRS hearing this, right? So can we have these systems that can help get to the answers for these simple questions and keep only the human interaction down for more complicated issues? Okay. It should hopefully then reduce customer service costs. I don't know that it actually does because people, before the cost was sort of they just didn't increase the number of people responding to emails or to phone calls. They just sort of let you wait. So that sort of assumes that they were boosting their telephone hours due to demand, which I don't know that they were, but in theory, this should reduce cost. Okay. Um, on the business side, it does allow you to see, okay, what are people looking for, and can we make that clearer on our website? Right. So like if people are always asking the bot to find X, it is not easy to find. So let's move it to the front page, right? So this could be used to improve user interface, user interaction, which makes people happier, right? Could be used to help understand current trends. So there are some obvious business implications there. Could be to create a positive experience for customers. Okay. And then we'll see. Right. So in wrapping all of this up, we've kind of like wandered through this space, much like having a conversation with GPT about some of the old systems, the new systems, their purpose, their points, where things are kind of headed until the next big innovation. And then these slides are useless again, but hopefully not. And let's talk about what have you learned, right? So we've talked about the types of chatbots and the terminology. So if you get into this space, understanding what NLU means is going to be important. What is a dialogue? What is an intent? What is an entity? Because even in the newer systems, you might want to guide them in certain ways, creating, help tuning the model, maybe not a hybrid system, but making it focus on the right stuff, for example. Okay. And then how are NLP tasks that we've talked about have helped us put together, could help us put together a chatbot, right? So entities, huge component to this. Parsing, part of speech tagging, very large component, sort of embedded in these models pretty naturally. text summarization. So if you're asking it to take something and explain it to you, right? And then machine learning is, we did the simpler forms of classification, but many deep learning models are doing machine learning at like a small level. What word should come next? What is the intent here, right? So it's just kind of like machine learning on steroids. Okay. We did not do simple chatbot creation with Rasa. I missed taking that one out. But if you want to learn about it, these slides are still available from the old system, and the old video is also still available where you can walk through an example of Rasa. If you have the appropriate type of it and or they've released it in open source, I'm imagining that they're just kind of like the newest thing is paid and then earlier versions are open source, but we'll see. Okay. And then sort of why are they useful? For me, useful helping with coding. That has, I don't know if it's sped me up or not. Hmm. It's a good question. I think about this a lot. Like, has this made me faster? Has it solved many of my problems? 100%. That it helps me maybe get to an answer faster. But I often wonder if that's because I already knew coding and I'm just applying it to a new language. And so I would love to hear feedback from folks who are learning coding for the first time, if that actually is helpful with all of its explanations, or if it allows you to get stuck faster because you're just copying code and maybe you didn't totally get what it was doing. So, the usefulness will depend on your use case. But they think if we think about it from a purely money-making perspective, they clearly have their use. People clearly like them, so they are useful things to have for satisfaction and or interaction purposes. And then on our own entertainment levels, are they useful? Do they make some task for me much easier, for example? All right, and so that is the end of the semester. You made it to the end. Congrats. And I hope that you enjoyed it and that you've learned at least a whole lot. And I will see you in the next class.